All right. Okay. All right, it's recording. So if you don't mind, I just repeat a little bit what I just talked about. Okay. Okay. So this tuning fork, when you strike it, it produces sound. Now, step one, remember this. How the sound produced? It must start with vibration. Okay. So here is we have the vibration of vibration of what? Vibration of particles, or you can say like source. Okay. Now every sound must have a source. For example, when you sing, what is your source? Where is your source? Your vocal cord. Okay, in your throat, what your vocal cord. When you play the guitar, where is your source? The strings. When you play the piano, okay, the note inside the piano, right? So you must have a source. First is it starts from the vibration of particles of source. Now you know particles, right? Particles is the tiny everything, every object is made of particles, right? So it starts from vibration. So vibration produces sound. And how does sound transmit? How the sound being transmitted to our ear? Let's say you're at a distance from the tuning fork, right? How come you can hear the sound? How is it transmitted? Now, the space between the tuning fork and your ear, we call it the medium, right? So this one is the medium. In other words, it is the air between the tuning fork and your ear, right? Now, medium, if we zoom in, let's take a manual zoom, okay? The space between your ear and the tuning fork, there are air particles, right? There are air particles. So let me draw it out. So it's blue color. These air particles. Now, how does this air particles helps to transmit the sound? First, it starts with the vibration, right? Vibration of this tuning fork. So if you zoom in this tuning fork, the particles starts to vibrate. Now, what happens is that as it starts to vibrate, it will cause the surrounding air particles to vibrate as well. Okay, so which one is the closest air particles? This one, the first one, right? This one. So this particle, it will start to vibrate. It will transfer the vibration to this particle here. So how does the particle vibrate? It vibrates back and forth, okay? Left and right. So let's say I just plot 3 points. First point is the center. We just name it point A, okay? Center of the particle. And then point B is somewhere here. Okay, let me draw it again. Okay, here is point B, and here is point C. Okay, now how does the particle vibrate? First, it will go to point B. Okay, it moves to the right, and then it moves back to point C, and then all the way back to original position. This is how it vibrates. Okay, so in other words, it moves back and forth, not up and down. It's left and right. All right, so this is the vibration of the first particle. Now, as the first particle moves to point B, what happened? It will knock on the next particle. Okay, it will knock on the next particle, and then the next particle, this one, will also repeat the same process. Okay, it will also start to vibrate, and it will move to the front, backward, and come back to the original position. And as the second particle moves forward, it will also knock on the subsequent particles. Okay, and every particles, all these subsequent particles will follow the same process. And this is how the vibration is transferred. Okay, now, what do you see if this keeps on repeating? It's like the first particle knocks on the second particle, the second knocks on the third particle. This we call the transmission of sound wave. Okay, this is, we call, write this down, transmission sound wave. So you will see a wave. Okay, you'll see a wave, and that is the energy. All right, so remember this, wave equals to energy. Okay, you see a wave moving from left to right. Now, remember this, in sound wave, energy is transferred. Energy is transferred, okay? First one is energy transfer, and second one is what? Remember this, the energy transfer do not carry particles. What does it mean? Meaning that if you look at the first particle, this one, wait, this one, the first particle, does it go from its position, like move to the back? No, it stays at the same position, right? It just vibrates. Right? What did I say just now? It moves to point B, moves back to point C, and then all the way back to original position. Right? It does not displace, it does not move to the back, right? It just stays at its original position, meaning that as this wave travels, the particles do not move. They just vibrate at their original position, which is why this means do not carry particles. Okay, the particles does not move along with the wave, only the wave itself, right? Now remember that these 2 points, transmission of sound wave, first, wave is the energy, and second, it does not carry particles. Okay, so how does particle vibrates again? Back and forth, okay, left and right. Okay, so this transmission, and eventually it will reach our ear, and our eardrum will pick up the vibration, and then we'll hear the sound. Okay, now let me repeat the process. First, it starts with a vibration of the source. So if you're singing, meaning that your vocal cord is vibrating. As the source is vibrating, it transfers the vibration to the air particles around it. Okay, as the air particles starts to vibrate, it will transfer the vibration to the next neighbor particles. Okay, to the neighboring particles, and then slowly it will repeat the same process, and eventually it will reach our ear. Now, can you hear sound in vacuum? Vacuum. What is vacuum? Vacuum is no air particles. It's like in space. Okay, it's like totally blank, no air particles. So if no air particles, how does sound travel? Cannot, right? That's why you don't hear any sound in space. Simply because there's no air particles to transfer the sound, right? So you cannot, in vacuum, there's like completely silent, no sound. Okay, now let me show you a example of this sound wave. Now, okay, before that, we just talk about the types of sound wave. There are 2 types of sound wave. Okay, write this down. There are 2 types of sound wave. First is longitudinal wave, and second is transverse wave. Okay, there are 2 types of wave. First is longitudinal, and second is transverse. Now let's see what is the difference between these 2. Longitudinal, write this down, vibration of particles in the same direction as the energy, as the wave propagation. Particles vibrate back and forth. Okay, now for longitudinal wave, the vibration of particles is in the same direction as the wave propagation. What do I mean by this? Now, let's take the previous example. So this is all the particles. Okay, here. Now, as the first particle vibrate, move here and back, right? Back and forth, and it knocks the second particle and repeat the same process, and the third particle also repeat the same process. And then you'll see where is the direction of the wave going here. This is the direction of the wave from left to right, right? Left to right. Now, if you compare with the vibration of the particles, where is the direction of the vibration? The vibration also goes left, right, right? Left, right. So if the vibration of particles is same as the wave propagation, meaning that the transfer of wave, okay, the direction of the wave moving is the same, then it is a longitudinal wave. All right. So an example of this would be like a string. You just imagine a spring, a very long spring. Okay, I draw it like this, very long spring. What happens if you push the left end here? Give it a sudden push. Okay, what happened? What do you see? You see that there's like a wave-like structure moving from left to right. All right, like each coil of the spring will move left to right, and then overall you'll see like a wave moving from left to right, right? Okay, just imagine that. This is an example of longitudinal wave. Okay, if you focus on one single coil is moving left and right, and also the wave structure is also moving from left to right. So this is an example of longitudinal wave. So sound wave is a type of longitudinal wave. Okay, remember that sound wave is a longitudinal wave. Now let me show you a animation. Let me show you an animation of this wave, because it's very hard. Sometimes it's very hard to imagine just by talking here. I have to show you some pictures, some motions. Okay, just a second here. Let me bring up my Google. Okay, let's do longitudinal wave motion. Okay, wait, let me choose there's one very good example yesterday I saw. Okay, let me try longitudinal wave animation. Okay, this one. Now you see this one. Now see this? This is longitudinal. Let me wait. This one here. Now see the particles. The particles is now in line, right? So see how the particle vibrates. It moves left and right. Now, where do you see the wave traveling? Also left to right. So the vibration of the particles is same as the wave direction. So this one is an example of longitudinal wave, right? Remember this one. And an example would be sound wave. Yeah, sound wave travels like this. Okay. Now, if you look at the spring, the example, this, I think we have more examples here. Now, this one. Let's see. Okay, this one is not moving. this one. Okay, it's not moving, never mind. Okay, I just, okay, yeah, this one also longitudinal. Wait, this one, but this one is not that clear lah. This one is because of the picture is not that clear. Okay, you see this one on top, this one is diagram. Yeah, this one is also longitudinal wave. So you see, if you see clearly this one, you see the red line. How does the red line moves? Left and right, right? And it produces like this, all these wave structures moving from left to right. And you also see that overall you see there's an invisible wave traveling from left to right. So longitudinal wave. And look at the diagram below, this one, the spring. Okay, now what happened when you push one end here, left end? You see like there's area where the coil are pushed together, and there's area where the coil moves further from each other, right? The region where the coil moves together, like pushed together, is we call compression. Okay, this one we call compression. Okay, you can just draw out the spring. Okay, this is compression, and the region where the particles or the coils are pulled apart from each other, we call it what? We call it the rarefaction.
Teacher,
Is it?
teacher.
What, yeah.
So where is the longitudinal wave actually traveling in the direction?
What is it? Where is the direction?
Actually, where is the wave traveling at the diagram?
The wave is,
The
oh yeah. If you look at this diagram here, the wave is traveling from left to right.
oh,
Can you see that? It's very hard. Okay, this diagram is a little bit hard to see because there is some wave traveling, like there's some wave being reflected. You see like some particles go to the right and some particles come back and goes to the left, right? So a clearer picture would be the one that I've shown you just now. Okay, later I'll show you again. Okay, so the wave is moving from left to right. It's moving from left to right. Okay, you see the red line, this one, the red line is creating the wave. It's creating the wave. Okay, so this one, the area where the particles are pulled apart from each other, we call it rarefaction. And the area where particles are pushed together, okay, we call it compression. Right, let me show you again the picture. Just now, yeah, this one. Where do you see the wave traveling? Does it seem like it's going from the right to left? No, right? It seems like it's going from left to right. Right? Here, this is the wave. So this is an example of the sound wave. This is how it travels. Okay, let me reply one message to Jia Yuan first. Really, the okay, let's continue. Let's continue. Okay, so this is longitudinal wave. Now let's go to the second type of wave. What is it? Transverse. Okay, transverse wave. Now what is transverse wave? Write this down. What vibration Okay, now transverse wave, the vibration of particles does not move in the same direction as the wave propagation. Okay, so example, let's say you have like 1, 2, 3, 4, 5 particles. Okay, let me use another example. Just imagine that you have a rope and the right end is tied to a wall. Okay, so this point is fixed. Okay, you have a long rope, one end tied to the wall, and you're holding here the left end. You're holding here. Imagine if you do a very quick up-down movement. What do you see? You'll see a wave like this. Right? This is the wall. This is what you see. If you suddenly like you flick the rope. Right? So this is an example of transverse wave. So how is it different? So if you were to mark a red dot here, let's say you just take a marker pen and then you mark a red dot here, and observe how the red dot moves when you do the up-down movement. Okay, you do the up-down movement and you observe how the red dot moves. It will move up and down. If you only focus on this one single mark, right, you'll move up and down, but you'll see the wave is traveling from left to right. Okay, I repeat, the wave is traveling from left to right, but the particles is moving up and down. You see the difference here? You see the difference here? Okay, so I'll show you another animation later. Okay, so just imagine if you have like in a stadium. Okay, just imagine in a stadium, right? In a stadium, you have many people sit in a row, right? Like the first row, second row, third row, fourth row, and all the way to the back. Just imagine the first row people, the people in the first row, they stand up and they sit down. Okay, they stand up and they sit down, and then comes the second row. The people in the second row repeat the same process. Stand up, sit down, and the third row, stand up, sit down. The fourth row, stand up and sit down. What will you see if you are an observer from a distance? You'll see like there's a wave created by these people, right? Right, you see there's a wave traveling from the front all the way to the back. Now observe how does the people move. Let's treat the people as the particles. Okay, let's treat the people as the single particles. Okay, now all these people, they're just standing up and sitting down. Right, for example, the people in the first row, they don't move to the last row, right? They just stay at their same exact position, standing up and sitting down. So how does the particles vibrate? Up and down. It does not move. It does not displace. It only moves up and down. But there's a wave traveling from the front to the back. This is an example of transverse wave. Right? So transverse wave is not, sound wave is not a transverse wave. Okay, so an example of transverse wave is light wave. Okay, so we don't talk about this first. This one, because you have a whole chapter of light in the, I think it's chapter 8 or 9. Okay, later we'll come to this light wave, right? So just know that light wave is a type of transverse wave, and sound wave is a type of longitudinal wave, right? Now let me show you the animation. Let's see if we have any good one. Okay. Let's do transverse. Okay, it won't move here, this one. Okay, this is not nice. Let me find if there's a good one.